Hello folks. Today we are going to discuss chapter 1, which provides general information about operating systems. So first we are going to discuss what an operating system is, and we are going to look at the organization and architecture of a computer system, which will be followed by the structure and the operations provided by an operating system. We will also briefly talk about process, memory, and storage management by the operating system. So, what are the objectives of this course and this chapter? First of all, we will be describing the basic organization of a computer system, the components of an operating system, and have a tour of these components. We're also going to give an overview of different types of computing environments. So, first things first, what is an operating system? An operating system is actually a type of software that works as an intermediary between the user of a computer system, which is typically the human being, and also the computer hardware, which achieves that. So the operating system targets executing the programs requested by the user and also try to make solving the problems of the user much easier. It also makes the computer system more convenient to use, and of course, while doing all these, increase the performance and efficiency of the computer hardware, which means make use of the hardware as much as possible. So, if you look at an operating system or a computer system in general, you can divide it into four components. The hardware, which is the tangible parts like your monitor, keyboard, mouse, or the CPU, the memory chips. These are the tangible parts of an operating system, of a computer system, sorry. The operating system itself, which is the topic of this course. The application programs, which are actually doing what the user requests. For example, all the programs you're writing are the application programs or tools we're using. Like at the moment, I'm using PowerPoint. You could be using Word, a calculator, anything. These are the application programs. And the users, which are typically the human beings, but in fact, as you already know from daily life, and you're going to see more during this course and other courses in the department, the user itself could be yet another machine. So you could have human to machine interfaces, or you could also have machine to machine interfaces. For example, consider autonomous cars. You will have a small computer system where the thing that makes a request from this computer system is not necessarily the driver, but for example, it could be the engine of the car. So the user of that system in that case would not be the driver, but the engine, which is actually, of course, controlled by the driver. Or it could be other computer systems. Now, the operating system in this case is making use of the hardware to achieve the requests of the user, which are implemented by the application programs. So there could be multiple programs requested by the user running simultaneously. For example, you could be running say PowerPoint, but meanwhile you could be listening to music, say on Spotify. So you could have both of them running at the same time. So all of these will be achieved by the same hardware, which is your computer. For example, if you have a single CPU, that single CPU should both be able to execute the instructions of PowerPoint, but also Spotify. So, which software makes use of the CPU at a specific time? It is the task of the operating system to decide on this, and also to control this operation. Like Spotify should not be consuming too much CPU power, because in that case PowerPoint will fail, and vice versa. So it is the operating system who decides how much of the resources are allocated to which process, and also making sure that the decisions made by the operating system are abided by the software. In other words, uh, a process, a software, does not capture the CPU and never release it. We don't want this to happen. So it is the operating system who is taking care of that. There are, of course, more things that are done by the operating system. For example, you would like to make sure that one user on that system is not able to read or modify the files of another user. So in that case, for example, security comes into play. Or you would like to provide utilities for accessing the network. You would also like to provide utilities for others to access your computer system over the network. For example, you have a website running on your computer, but you would like to make sure that they can only access some HTML pages, but not the others. Or they cannot modify things on your computer system. All these functionalities are achieved by the operating system. So, in other words, the operating system does really have a very important role in a computer system. So, we can visualize these four components as in here. We have some number of users. In your case, if you look at your personal computer, typically you will have one user, which would be yourself. But for example, if you're sharing your computer system with your brothers and sisters, then you could have created several user profiles on that computer system. Well, typically it would be either you or your brother or sister who's using the computer at any specific time. But actually, we know that it is possible to remotely connect to a computer and run things in parallel. Okay, so in other words, there could be multiple users executing tasks simultaneously. So the operating system typically should provide such a multi-user environment. And that's what we are going to discuss in this course. Well, these are the users, typically the human users, or some of them could be, again, as I said, machine that are acting as the users. Now, these users are making use of some system and or application programs. Like you could be writing a program, so you could be using a compiler and an editor, assembler, text editors like Word. You could be making use of some database systems. You could be making use of actually several of these. In this figure, simply here, each user appears to be executing a different and a single application or system program. Actually, typically you will be executing many of these. Some you will be aware, some you won't. For example, if you are using a cloud system like Dropbox or Google Drive, you're not aware of it typically, but in the background, that system is actually synchronizing your files. When you edit a file in Word or PowerPoint and you save it, actually Dropbox is in the background syncing it, running in parallel to your application program, which is Word. Anyways, these are the application programs that you're interested in because you're using actually those programs. You're not aware that you're using the operating system, but actually the operating system is always in the loop, making sure that these applications are running in a secure manner and with maximum efficiency, which means, well, you have purchased this computer system and you would like to make best use of it. So it is the operating system that's managing all these. And it is your hardware, your computer, that's doing all this. So, in other words, the application programs are trying to make use of the hardware, but they cannot use the hardware directly. They have to go through the operating system. So, these application programs ask the operating system to do something on the hardware. Once again, your application programs like your text editor cannot display even a single character on the screen. When you try to display something on the screen, when you hit a key on the keyboard, say you hit the T key on the keyboard, it is the operating system who understands a character is a key is pressed on the keyboard, understands that it is a T character, and decides which of the applications on the screen should get this T character, passes it to that application, and that application says, well, if the user has pressed the T key, then display T at this position. Now, on your screen, you might have several applications, several windows appearing, and whichever window is to display that character T, it is the operating system that makes sure that T goes there. If the operating system was not in control, an application could be displaying characters on another window, either by mistake or intentionally, and that's something we don't want to do if we really don't mean it. Okay, so it is the operating system who is always communicating with the keyboard, with the CPU, with the monitor, with the mouse, whatever, with your network card. It's the operating system that is making use of the hardware on behalf of the application programs. Your application programs cannot directly do it. You cannot write a single byte or read a single byte directly from the hardware. So, what does the operating system do? Well, we could define it from different perspectives. The users want convenience. They just want everything to be used very easily, so they want ease of use, and also at the best performance. They don't care about resource utilization. A user does not care whether the disk is allocated to this process or the other process. The important thing is I want to read from the disk. Reading from the disk should be easy. It should be just like I want to read from this file, this thing. That's it. And also, I would like to make use of the disk in the best way, which means I want to read from the disk. I want it available as soon as possible. The idea is always as soon as possible, as fast as possible, the largest possible amount. But how that's done, the user does not care about that. But if we're talking about a computer system on which several users run their applications, like in the case of a mainframe or a mini computer, which is shared by several users, well, it's not only you. There's so many users that are making use of that system. So the system wants to keep all of the users happy. In the case of a dedicated system where you have a computer system, typically a workstation or PC, whatever, that's dedicated to a single user, then things could be slightly different. You can have some dedicated resources to specific users, but you could also have frequently used shared resources, for example, from servers. You can have handheld devices, for example, your phones or tablets, whatever. They have limited resources, limited processing power, limited memory. that are optimized for usability and also limited, again, battery life, which is to be optimized. But note that when we talk about, for example, handheld computers, suddenly we have also some other features we typically don't have in our typical computer systems. Like we have touch screens, although you also have touch screens on some computers nowadays. Typically, they're provided on uh, handheld devices. You have, for example, typically a GPS for localization to find your position so that you can use it in Google Maps or Yandex, whatever. Typically, the handheld devices have internal sensors which we don't have on most computer systems, so that the device understands whether it's being held uh, up or rotated, so that the image on the screen, for example, if you're watching a video, automatically rotates. So things could be different in different computer systems. And some computers have little or even no user interface, because actually those computer systems are not meant to be used by human users. This is what we call embedded computers, because these are embedded to a larger cyber physical system. For example, in the cars, if you look at the cars, the modern cars today, they have many processors inside the car. You're not even aware of that, but typically the engine itself is being controlled by a computer system with which actually the driver is not communicating directly. The driver is uh, just trying to speed or stop or rotate the direction of the car. However, there are multiple processors that are executing and interacting with each other, not directly with the driver, to achieve this task. If you look at Wikipedia, you can see that 98% of all processors that are being manufactured are actually used in embedded systems, not on your computers. You have processors almost everywhere, though you're not aware of it, like in your refrigerators, in the elevators, in many different places. They all have embedded processors in them. Uh, well, you can look at the operating system as a resource allocator, because we have resources. What do you mean by the resources? The resources are the disks. You can even look at soft items as resources, like the files are also, they could be considered as resources. The keyboard, the monitor, the mouse, the network itself, all these are resources. Also, services like the web service, file service, all these are resources. So the operating system is acting as a resource allocator. This resource is allocated to this application for this task for a limited time, and when the task is achieved, I will reallocate the same resource to another application. It decides between conflicting requests, because you could have multiple applications trying to make use of the same resource. But of course, you cannot allow that. So there is a conflict in the request. So the operating system decides who gets that resource at that very moment. So it tries to increase efficiency, but also tries to be fair. If you try to increase the efficiency, note that typically efficiency and fairness are conflicting. You try to increase efficiency because this process can use that resource in a more efficient manner. You would always be assigning this resource to this process, but then the other process will starve. It will never get that resource. If you try to provide fairness, then your overall system efficiency will drop because this process gets the resource to be fair with the other process. But this is not using the resource in a very efficient manner. That means the overall efficiency of the system is dropping. From another perspective, the operating system is a controlled program. That control program actually controls the execution of other tasks, processes, and makes sure that we don't have errors in the use, intentional or not. Also, there could be improper use of the computer system, typically intentionally to give harm, or maybe not to give harm to the others, but at least increase your use of the system in an unfair manner. So it does also this control, and also it provides security, a very important concept, to make sure that one user is not able to access the resources of another user. There is actually no universal definition of what an operating system is. Some might say everything a vendor provides, ships into the box, is considered your operating system. Which means, for example, well, nowadays, of course, you even get download the operating systems. In the past, it was on CDs. Doesn't matter. For example, if you try to get Linux, say you want to use Fedora, you just download Fedora. It's a huge image file, a CD image. Whatever comes in that CD image, you could regard as the operating system. But in fact, instead of Fedora, you download Ubuntu, you will realize that they are very similar, of course, because they are both Linux distributions. But you will see that there are some different applications. So did the operating system change? Is that a different Linux system? If you compare Fedora and Ubuntu, no, they're both Linux operating system. What is the difference? It is the application programs the vendor ships in that image or CD or whatever you call it, that makes a difference. So typically, we will not be looking at so much into what the applications are. Of course, they're important for the user. That's why people prefer one flavor of Linux over another one, or Windows or MacOS, whatever. These are all different operating systems. These application programs are, of course, more important for the user. That's why one user prefers one over the other. But from an operating system designer point of view, we don't care about the application programs. What we mostly care about is what we call the kernel. The kernel is the very core of the operating system. It is the program that's running at all times. You start the computer and immediately the kernel starts running, and then the other applications programs load, and all those application programs need to go through the kernel to get something executed. So everything else other than the kernel, if you strip away the kernel, whatever remains is either a system program that comes in that operating system CD, whatever, or it's an application program that you have downloaded. Of course, application programs also come with the operating system just to make it more attractive.